Okay, today we are going to do a pull test on the screw piles we've been using to hold our dock in. We want to actually see how many pounds the screw piles can hold before they pull out, and we want to see what the difference is between a screw pile that's fully installed and partially installed. So this screw pile here we can see is just partially installed. The full length of the screw pile is here, and we can see that it's in approximately that far. So we're going to call that about halfway. And for our system, we basically have a cable and a weight system. And our weight we're going to use is water. So because our system has weight itself, I'm going to use a pull test on the system itself to see how much our initial pull is, and then we'll slowly fill it with water. Okay, so I'm zeroing out the meter. This is a fishing scale. It's supposed to be good in pounds and ounces. And we're going to see what the preload is on the setup. Okay, so it's coming up in the air now. So we're looking somewhere around 45 pounds preload. Okay. So now I'm going to hook it onto the screw pile. And we see right away that the screw pile starts to pull over in the sand a little bit. That is because there is this lever arm here, so it's going to pull sideways a lot easier. And as we fill our weight, we should see that screw pile actually pull right down and then slowly pull out. Okay, so we're just going to do some quick measurements on the barrel to determine our size. So our barrel is 34.5 inches long and 23 inches in diameter. Then what we're going to do is we're going to just slowly fill it with water, and we'll hopefully try and set up a little time lapse with the screw pile so you can see what's happening. And then I'm going to check the depth by the water line with the broomstick, and then we can calculate the weight because we know the specific weight of water. So we'll start adding water now. And we'll slowly see the screw pile gain tension. Okay, so we're going to check our water depth again. Let's run for a little bit longer. Okay. So our distance, we're now at 14 inches, which is just under half full. So we'll keep filling it. We can see our screw pile is definitely under some stress now. It's pulled over. And one thing I should mention too is we've got loose sand. Oh, that was the old screw pile hole. We're actually quite a ways, so it's fairly soft ground. I can push the broom in fairly far, so we're not actually hitting really solid ground yet. If we see that, if we're actually that far down, we're hitting sand to there and then mud. So let's just give that a quick measure. So 17 inches is where I push the broom down, and we're seeing mud starting at about 9, so it's about 9 inches of sand cover on top. So if we compare that to this spade here, the actual flighting is 4.5 inches. And if we go to 14 inches, that actually doesn't leave a lot of mud above the flighting. So that's pretty similar. The distance that I just pushed that in is pretty similar to the depth that the screw pile's in. And so right now we only have about 8 or 9 inches of solid ground, mud, above the flighting before it turns to sand. So I did some math on the barrel. The barrel that we are using is 8 cubic feet, and based on a weight of water of 62 pounds per cubic foot, the barrel should hold about 500 pounds of water. So that's 500 pounds on top of the setup pounds of around 45, I believe it was. So we just had failure of the screw pile. Now the screw pile pulled out slowly. You can actually take a quick look at it here. We'll see it's not right out of the ground totally, but it is loose. You can see that the starting point was here and it's out sideways. Now, we can actually see that the screw pile has bent also under the load. And it bent up fairly high, so that's typical. Now, that's because we didn't put the screw pile in at the whole distance. So, let's see how much water we have in the barrel. Okay, the barrel is fairly full. Just judging by that. We're at, I would say, somewhere between 2/3 and 3/4. So if we measure the depth, we are just over 2 feet. Maybe 24.5 inches. We do a quick ratio, 24.5 over 34. That's going to give us 72% full of water times the 500 pounds is 360 pounds plus the 45 pounds. So that screw pile was holding in tension 405 pounds, or about 400 pounds. So one of the things I forgot to do yesterday when we tested our screw pile about halfway in is to see the torque, how much torque it took to turn the screw pile. That'll give you an idea of soil type and density and how well the screw pile is going to hold. So what I'm going to do is I'm going to measure. We don't have 12 inches to give you a foot pound, so I'm going to go 6 inches and then multiply it by 2. So I'm going to get about 6 inches here. And we're going to use fish scale again. I'm going to pull on it until it starts to move. Okay, so we're at just under 20 pounds. And then we divide that by 2 because I'm only a 6-inch distance. So that's about 10 pounds in torque. So that gives you an idea of how much torque there is, to give you an idea of what the soil is like underneath. So now we're going to do a separate pull, or second pull test here. So this is a screw pile, same type of screw pile, put in the full distance. And you can see I've dug down in the sand a little bit till we've hit the mud. And we're going to do a torque test on this one here. So I'll double check my 6 inches. Okay. Zeroing the scale and hold it even in the center. Okay, so we're at about 34 pounds. So half that's 17 or so. So you can see there's quite a bit more torque once you get deeper down. So because our last test with the screw pile half in almost limited out on our water weight, we're going to start this test at it's about 375, I'll say 373 pounds in load off the start, and we've just started adding water now. So you can see we've definitely got some tension on the cable. The cable's looking pretty straight. And our screw pile here has already pulled over a few inches. It's at that just under 400 pounds in tension, and we're also got a little time lapse. We'll do the same thing. We'll fill the barrel to about a third full or so, and then we can check and see if there's any progress. I'm not sure if we'll be able to pull this one out once we get to, you know, that 900 pound mark or so. We'll see. I'm going to do a test to see how full it is here. We're at about a third. Which is about a foot of water. And we're not seeing any signs of stress on the, or movement on the screw pile yet. So we might just fill it right full and see if we get any movement. So while we're waiting for the tank to fill, I'm going to do another test with another screw pile in the water. So I hit fairly good mud, I guess you would call it, and then actually hit a soft spot. So we're going to do another torque test to see the foot-pounds, and then we'll do a pull test on it also to see where it was at. So, about there. I'm at like 13 pounds, so half that would only be 7 pounds torque. So we're actually quite low here. So this one's probably going to pull out quite a bit easier. Okay, so we're going to do another test, same test, screw pile in the water. And when I was putting the screw pile in, I felt like I was hitting kind of normal soil, and then I hit a soft spot. So where that soft spot was, we were only at 7 foot-pounds of torque. We've preloaded again to that 370, 380 pounds, and we'll start filling the barrel and see if it pulls out. While the barrel's filling, I'm going to pull out that other screw pile so we can see what it looks like. So we're at max weight, our barrel's overflowing with water. The screw pile is nowhere to be seen, but it's still holding quite well. I don't think it's actually moved that far. Oh yeah, it's actually right here. That gives you about an idea of distance. Just under a foot, it's pulled sideways at around that 900 pound mark. So that gives you an indication of how well they hold. What we're going to do next is we'll set up on that other screw pile in the water and see how it fares. Okay, so this is the screw pile that we did with the 900 pound test that was fully inserted. You can see it has a slight kind of continuous curve at the bottom. And then there's more or less straight at the top, a little bit orange right here. I think that was because in this case we had fairly soft soil for the first foot or so. In one of the earlier videos you can see I pushed the broomstick in and the broomstick almost fell in. So that's how that went. So that's pretty impressive to show 900 pounds in kind of medium soil conditions. Okay, so our second screw pile's backed out on our weight again at usually around 900 pound mark. What I'm going to do is we're going to shock load it. So we're going to go up to the winch on the Jeep and turn it on and basically lift it up, and it lifts really fast. So it's going to put that acceleration force on the screw pile plus the 900 pounds. I don't know how much that force is right now. I'd have to try to calculate out the acceleration based on the weight, and I don't know what the Jeep speed is, but we'll be able to see. And basically I want to see if it brakes or not. Front of the Jeep forward and down pretty good, so there's definitely lots of loading there. So the screw piles hold a lot. I would say well over 1,000. So we're seeing some pretty quick movement in the barrel right off the start when we were adding water. So you can see how much water is in there. We'll have to just kind of take into consideration that our barrel is not perfectly straight, so try to hit the center of the barrel. Very little water in here so far. 4 inches. Okay, so now we're going to do a drag test on the weight. So what we have is we have 2 weights, just like these ones here. The weights out in the water are 77 pounds each, plus the cable is going to be about 160, somewhere there, just under. And we're going to do the same thing. We're going to fill our barrel and see at what point the weight starts to slide. Now the ground out in the water is fairly stable, like it's not sinking in a silt, and the location that I put them in is fairly rock free. Now I've aligned the weights to kind of perform the best that they can, so the chain's in a straight line, one weight's in front of the other. So we worked out the water weight in our previous stop mark, the stop point, to be about 60 pounds. Plus the initial 45, which puts us just over 100 pounds in tension, is kind of where we started to see movement. We just added a little bit more water, and it just continuously slid to the ground here. So we're just touching the ground now. Do another test on approximate depth here. So we're looking to go here. That distance is about 6.5 inches. Okay, so we've got a total load of about 140 pounds in tension with 170 pounds in weight. So now what we're going to do is we'll add these last 2, and then we'll do the same test again. Okay, so we're restarted, got our weight back in the air, same way as what we had before. We'll start adding water. Okay, we've added 2 more weights, so a total of 4. I think we're up to 330 about in weight. We haven't emptied our barrel from the previous test, so we're just going to start from where it failed with just the 2 weights and add to it. So we've repositioned basically our weight up higher again, and now we're just reloading. So it is holding more after the weights have slid a ways. They've already slid or so. So I imagine we're getting a little bit of that dirt build up, which is holding up. Okay, so we didn't add much water, and we went back to the ground here, so we're going to see how much more we have. 10.5 inches. 10.5 over 34 times 500. About 154, plus we said 45 pounds of preload. About 200 pounds is when we started to see some movement. I believe the total weight out there was around 330. So I'm going to try one more test here. We're going to reset this up so we can lift it higher, because we will see some buildup in front of the weights, which are going to slow them down. I just want to see kind of if that's going to make a difference and how much. So we were able to add some more water. We just slowly saw the barrel come to the ground and actually pulled the water out, and it just continued to slowly sink. So we're on the ground now. Our depth is up to about 16.5 inches. So about 16.5 divided by 34 times 500 is 242 pounds plus the 45 pounds of chain and cable. It's 287 pounds. So we got 287 pounds in tension out of 330 pounds of weight and chain. That gives you a pretty good idea on our conditions at this exact location, how much friction concrete weights will create in a cable tent.